Let's just picture the modern battlefield for a second. You've got a column of armored vehicles rolling across open terrain. To the soldiers inside, everything seems completely normal. The sky is totally clear, radars are quiet, there are no enemy jets on the horizon. But miles above them, an unseen threat is just patiently circling, watching every single move they make.
So imagine that target, moving along, completely unaware it's being actively hunted. Hunted by a weapon that can scan the landscape, hide in the clouds, wait for the absolute perfect moment, and then strike with devastating precision. It really brings up a chilling question. How do you stop an enemy you literally cannot see?
Think about it. Throughout history, militaries relied on artillery or traditional aircraft, but those required either seeing the target directly or knowing exactly where it was before pulling the trigger. Well, we're shifting away from that. We're moving from dumb artillery to intelligent connected machines that actively search the battlefield. What if the missile hunting you didn't just follow a set arc, but could actually think, assess, change its mind, and maneuver in real time? Okay, so this brings us to loitering munitions, or what you probably know as kamikaze drones. Basically, they bridge the gap between a traditional cruise missile and a reconnaissance drone. See, unlike a normal missile that's just fire and forget, a loitering munition can actually be launched without a specific target in mind. It just goes up, waits around, and if the tactical situation changes, it can completely reroute. Or it can even abort a strike entirely if civilians wander into the area. A great example of this is the U.S. Marine Corps Hero 400. You can see those really distinctive double X-shaped wings. These platforms are absolutely packed with high-tech electro-optical and infrared sensors. So what does that actually mean? It means a human operator sitting safely miles away gets a live, first-person view of the target area. They aren't just staring at blurry radar blips, they're looking through a high-definition camera, visually confirming the target right up until they initiate an unstoppable terminal dive. Now, this is where it gets wild. Historically, the military's kill chain required a massive network. You needed satellites, aircraft, and artillery units just to find, track, strike, and assess a target. Loitering munitions compress that entire sequence into one low-cost platform. It finds the target, fixes and tracks it using onboard processors, finishes the job by diving in, and because it's streaming video right up to the exact millisecond of impact, it gives you instant battle damage assessment, all in one package. Section 1, Tactical FPVs to Strategic Strikes. Now, the term kamikaze drone is actually a huge umbrella. Militaries are fielding an incredibly wide variety of these weapons for completely different missions. We're talking everything from tiny, battery-powered quadcopters you can literally stuff into a backpack, all the way up to massive, jet-powered fixed-wing aircraft that need a dedicated launch vehicle and can fly thousands of kilometers. This gives us two very distinct combat roles that are defining modern warfare. On the tactical side, you have cheap FPV, or first-person view drones. We're talking maybe $500 a pop. Troops rig them with explosives for short-range attacks right on the front lines to bust armor. But then, on the strategic side, you have deep strike munitions like the Shahed 136 or the American Lucas system. These cost tens of thousands of dollars and are pre-programmed to fly autonomously deep into enemy territory to take out high-value infrastructure like air defense radars or power grids. Section 2, the economics of asymmetry. Okay, let's look at the financial shockwave here, because this is completely flipping the economics of war upside down. It's not just about who has the best tech anymore, it's about who can afford to keep fighting. Just look at this staggering cost asymmetry. A strategic drone like the Shahed costs around $20,000, but to shoot it down, an advanced military usually has to fire a Patriot missile, which runs about $3 to $4 million per shot. Think about that. If your enemy forces you to spend $4 million to destroy a $20,000 drone, they are winning economically, even if you blow their drone out of the sky. And that creates a frankly devastating cost-exchange ratio. I mean, we've seen actual scenarios where two $30,000 kamikaze drones slip past defenses and completely destroy a $1 billion early warning radar system. $1 billion? That is a 30,000 to 1 return on investment. It means smaller nations or even non-state groups can suddenly project high-precision strikes that threaten the most expensive military hardware on the planet. It's a total game changer. And the macroeconomic impact on the ground is just undeniable. Get this, recent data shows these cheap, expendable drones are responsible for over 60% of armored vehicle losses. 60%. Defense economists are actually estimating that because of this constant aerial threat, the operational value of a traditional multi-million-dollar main battle tank has literally been cut in half in modern combat. Section 3. Swarm tactics and countermeasures.
Now, one drone flying around at a couple hundred kilometers an hour, that's a relatively easy target for modern air defense. But the ultimate nightmare scenario for a commander is the swarm. Imagine firing hundreds of these drones all at once. It completely saturates radar systems and just exhausts missile reload cycles. Swarm tactics prove that overwhelming volume defeats precision every single time. When a swarm comes at you from 360 degrees, mixing fast jets with slow propeller drones, air defenders are forced to make impossible choices. They burn through their expensive missiles until the final waves just slip right through untouched.
So naturally, there's a desperate race for countermeasures. The low-altitude airspace is right now the most contested domain in modern warfare. Militaries are frantically deploying layered defenses. They're using intense electronic warfare to jam GPS and sever control links. They're testing directed energy like high-powered lasers that cost pennies to fire. And on the ground, troops are literally welding metal cage armor onto their vehicles and heavily relying on decoys to trick the drones into hitting fake targets. It is a wild scramble.
Section 4. The autonomous future. Okay, let's talk about where this is all heading, because the next generation of these munitions is straight out of science fiction. The crazy pace of innovation has led to kamikaze drones equipped with turbojets, giving defenders barely any time to react. We're seeing stealthy electric motors that completely remove that acoustic warning sound troops rely on. But the scariest part? Edge AI integration. We're talking about machines that can independently identify, classify, and track targets without any human input at all. And because they don't rely on a communication link, they are completely immune to electronic jamming.
Just listen to this quote from a frontline commander. It really hits the nail on the head. When a drone costs $400 and a traditional shell costs 10 times that, even using multiple drones to destroy one tank is a huge win. The barrier to entry has permanently fallen. War isn't about that single, multi-million-dollar decisive strike anymore. It's about cheap, relentless, unbearable pressure. The ability to churn out and deploy tens of thousands of these systems is the absolute new standard of military power. So as AI gets more advanced and we start seeing swarms that can communicate and hunt together like a collective hive mind, we're really staring down a very quiet arms race. It leaves us with a chilling final question, and honestly makes you wonder how fast the battlefield of tomorrow is going to evolve. Will future wars actually be fought by human soldiers? Or will the skies just be ruled by intelligent machines waiting, thinking, and searching from above?